Welcome to lecture series 8051 microcontroller. In today's session, we will discuss about timers and counters in 8051. It is one of the important topic which is leads to the automation purpose. In today's world, the industry automation, home automations, everything is depends on the timer. So, based on the timing, it will automatically do the work and also it replacing the manual work. So, now we will discuss how the timer will function in the microcontroller or for any specific applications. So, for the particular application, it will run the counts, right, after 5 minutes or after 100 packets. For everything we need the counting values. So, how the counting function is performed, either by based on the timings or based on the quantity. How it is functioning means based on the system clock pulse. So, every processor or every microcontroller or every design of the system having its own frequency, that is operating frequency. So, based on the frequency we are generating the pulses. Okay. So, it will start to count the number of pulses. The pulse is nothing but one on and off period, that is a complete cycle. So, it will count the number of pulses. So, how it was counting, based on that it used as a either timer or counter. When it will count the system clock frequency pulses, then it is called it as a timer. Suppose externally we can generate some other waveforms or some other pulses. When it count from the external pulse, then it is called it as a counter. Okay. Only the difference source of the oscillation or source of the pulses. Whether it is the internal pulse, then it is called it as a timer. Whether it is the external pulse, then it is a counter. Okay. So, we will enter into the lecture. So, in today's session we will discuss about what is counter, what is timer, what is the difference between these two, and what are the special function registers supporting for this counting and timer purpose, then modes of operation along with some simple program. Counter, it is programmed to count the external clock pulses, right. So, when you are starting with the external clock pulses means it internally the 8051 supporting with the two 16-bit registers which are T0 and T1, okay, which are timer register T0 and T1, two 16-bit registers which are used to generate the external clock pulses. Based on the pulse it will counter, that is the counter. So, the counter can be initialized with either up counter or down counter. Up counter means the value will be increased, in case of down counter the value will be decreased. At the same time you can initialize the counter value as either 8-bit or 16-bit values. Based on the user requirement you can use it as a 8-bit counter or 16-bit counter. The counter will count the binary values or in the BCD values. So, how it is stored means either in the 8-bit form or in the 16-bit. In case of 16-bit we can use the T0 and T1, two 16-bit registers we can use it. For 8-bit purpose it will be splitted as two registers, higher register and lower register. Then it will be denoted with the corresponding register format TL0 and TH0 for the two 8-bit registers to initialize the 8-bit counter values. In case of T1 it will be splitted as TH1 and TL1. Okay. So, these are the four 8-bit registers, these two are the two 16-bit registers. So, based on your count value, either it is 8-bit you can use it in the any one of the four registers. In case of 16-bit you can use the T0 or T1. Then the BCD value will be either in the binary format or in the BCD format. Another one is timer. It is one of the counter which is used to count the internal clock pulses. Internal clock pulses means the system itself having the crystal oscillator, based on that it will generate the frequency. So, its operating frequency is varied from 1 megahertz to 16 megahertz. Among that any one of the frequency we are taking for our applications, then that frequency is divided by 12, because that is a one machine cycle which consists of the 12 pulses. So, to calculate for the pulse rate for single one we have to divide it by the 12. Then the count value will be loaded in any one of the 16-bit register, either T0 or T1. The count value will be loaded in any one of the timer register T0 or T1, both are the 16-bit registers. The next one is special function registers. This is one of the important one which is used to define the function of each. That is, we have a two kind of special function registers, one is T mode, another one is TCON. T mode is timer mode, which is used to define in which mode the timer is planning to work, okay, because it supporting the 8051 will support the 4 different modes of operations. So, based on that format we have to select it. This is like a control word format which is used to interface the hardware with the software. By coding itself we can control it. It is a 8-bit format. Another one is TCON, which is a timer control. Based on the name you can understand, which is used to control the timer function. Control the timer function means when to start, okay, then when to stop, this kind of additional informations. Along with that, the timer is run on T0 or T1, this will be used in the TCON. So, for any kind of timer applications we have to activate the T mode and TCON register. This is a format of TCON. The TCON, which consists of a 8-bit registers. Among the 8-bit register, the first 4 bit is used for the interrupt purpose. The next 4 bits are used for the timer. Among that, we have 2 external interrupts which are INT0 and INT1. For INT0, first 2 bits are reserved, the next 2 bits are reserved for the INT1. Okay. So, totally 4 bits reserved for the interrupt. Among that, first 2 is used for INT0, the next 2 for INT1. These 2 bit positions for each interrupts, the INT0 which is used to enable the interrupt type, whether it is a edge trigger, right, mostly the flip flops are activated to activate the interrupt with a either positive level triggering or edge triggering. Level triggering means the signal will be passed like this, right, this will be activated either with the high level or with the low level. So, this kind of activation will be called it as a level triggering. Suppose you are using the pulses to activate the device when the level is changing from low level to high level or high level to low level. So, this one is positive edge triggering, this one is negative edge triggering. The positive edge triggering means which indicates the level changing from low to high level. The negative edge triggering means the level changing from high level to low level. So, the IT0 which is used to indicate the edge triggering either in the positive edge triggering or in the negative edge triggering. When the bit position is 1 means it indicates the positive edge triggering, which indicates the level changing from low to high level. When the bit position is 0 means it indicates it is a negative edge triggering when the level is changing from high to low level. Okay. So, IT0 is used to indicate either positive or negative edge triggering. The IE0 is used to activate the external interrupt INT0. The same thing repeated for the INT1. Now, we are moving to the next 4 bits. Among that, first 2 bits is used for the T0 register, next 2 bits used for the T1. The 2 timers, 2 16-bit timers which are T0 and T1, which are represented with the 2 bit positions. This one is timer run. Timer run means when the bit position is 1 means it start the run. When the bit position is 0 means it will stop. So, to activate the timer, the TR0 should be 1 for the T0 timer. After starting, the bit positions are changing, right, the timer will start to count. When the level is reach the maximum value, then automatically it will indicate the timer overflow flag. TF0 is timer overflow. When the bit is 1 means overflow is occurred, when the bit is 0 means no overflow. Okay. So, based on the TF0 we can understand the status of the timer, whether it exceeding the limit or not. So, these functions are repeated for the timer 1. To start the timer 1, the TR1 should be 1, then whenever the overflow is occurred, suppose if you are using a 8-bit register, then from FF2 the value changes to 00H means then the TF1 will be active. Okay. So, the TCON register, which is a timer control register having 8-bit positions, among the 8-bit 4-bit is reserved for the interrupt, then 4-bit reserved for the timer. In the timer we have a 2 16-bit register T0 and T1. For T0 we have a 2-bit position and T1 we have a 2-bit positions. The main function is to start the timer and to check the timer overflow. We will move to the next one, which is T mode, which is a timer mode. The timer mode, which is used to indicate what type of mode is you are activating and whether you are using the device or application for the counter or timer purpose. Okay. Additionally, the gate signal is used to control the operation. So, among that, first 4 bit which is used for the timer 0, next 4 bit is reserved for the timer 1. In this, we have 2 modes M1 and M0. Based on the position 0 0 means it represents mode 1, that is mode 0, right. 0 1 is mode 1, 1 0 is mode 2, 1 1 is mode 3. So, based on these 4 combinations, we can select any one of the modes. Each mode operations will be discussed later. Then the C by T bar, which represents the T naught, can be used as either counter or timer. When it is 1 means it activate it as a counter. The counter which is used to count the clock pulses from the external. When it is 0 means it acts as a timer which is used to count the internal clock frequency. Okay. The gate is one of the important function which is used to activate. When the gate is 0 means it will start the timer. Okay. Along with the T-con, which are TR naught positions, the gate also playing a vital role when to start the timer. Okay. When the gate is 0, it automatically start the timer along with the TR1. Otherwise, when gate is 1 means depends on the interrupts INT naught or INT 1. Okay. I will give it as INT x, which represents either 0 or 1. When the gate signal is 0 means it automatically take the decisions along with the timer TR bit position. If it is 1 means it depends on the INTX. The INTX, which is the interrupt signal INT naught or INT 1, should be 1 to start the timer. Okay. So, the same function is repeated for the timer 1 along with the 2 modes, that is 2 bit positions for mode positions. Any one of the mode we can select it, then we can use it as either counter or a timer, then position of the gate. So, these bit positions only define which timer we are using. Okay. Because we have to write the corresponding ones and zeros bit positions, then we have to activate. Suppose I am asking to activate 8 bit counter value. Okay. Suppose you consider mode or initialize the timer in mode 0. Okay. Initialize the timer in mode 0. So, in that case what you will do? Initialize timer in mode 0 of T naught register. T naught register means automatically I have to give here 0 0, then timer I am asking. So, this bit should be 0, then the gate is always 0, timer 1 is not using. So, simply you can put it as a 0 0. So, whatever the word 0 0 h. Now, while starting writing the program, you have to write it as move T mode comma 0 0 h. Suppose I am asking you to initialize T1 register in mode 1 as a counter. As a counter means what you will do, here you put a 0, then counter it should be 1, this is a mode 1. So, bit position should be 0 1. At the time T naught is not used, so you can give it as a 0 0 here. Now, you read what is the value of this. This one is 0 1 0 1, which is 5, another one is 0. Now, we have to initialize the program move T mode comma 5 0 h. So, based on this it will understand. Okay. Now, the timer 2 is initialized, the T1 register is initialized in mode 1, which is act as a counter. Okay. This is a general structure which is used to define whether it is a counter or a timer, who will generate the clock pulses and when it will start. Okay. So, this one is the oscillator frequency which are used in the 8051 microcontroller. After generating the frequency, it will generate the frequency maximum of 1 to 16 megahertz. Okay. So, any one of the frequency based on our requirement, we will select it. That frequency is given, then it internally divided by 12D, because we want only a single pulse. This is a group of pulses, that is for 1 machine cycles. So, divided by 12D, then it will give the signal for the or pulse. Here also we are getting the pulses for timer. Okay. The another one is either T1 register or T0 register, we are initializing some values, or externally we can connect the some hardware devices to generate the pulses. So, based on the pulses, now the pulses are generated. This is one of the MUX multiplexer, which is used to select any one of the function, right. You can consider this as a I0, this one is I1. Okay. So, this is one of the signal which will be activated by using the C/T bar. When the C/T bar, what it indicates, when it is 0 means it will pass the I0 signal, which is a timer. When it is 1 means I1 will be selected, then it will be passed as a counter. So, either you can select it as a counter or timer by using the C/T bar signal. Okay. So, now the pulses are available, any one of the pulse, either internal pulse or external pulses are available on here. Now, I have to start the counter. When the count will start means depends on the 3 signals. The 3 signal is, first one is timer run in the TCON register. In the timer control register, TR bit should be 1. If it is 1, then only the timer will start to count. At the same time, the AND gate having the 2 signal, what it represents, the TCON should be 1 and any one of the signals should be 1, then only it will start. Okay. If both signals are start, then will get the conducting state. Suppose if you are giving this kind of pulses, then it will start to count one on and off period. So, this is 1, this is 2, 3, 4, 1, 2, 3, 4. After that, we have the counter value was 4. Okay. So, the number of pulses will be counted. Okay. So, the another input in the AND gate is depends on the gate signal and INT signal. The gate signal should be 0. If it is 0 means automatically the signal is 1. Because of OR gate, any one of the input is 1, we will get the output as 1. Okay. So, this signal will be passed. Otherwise, if it is 1 means that time the INT not should be 1, then only you will get the 1 signal, right. Because the gate signal is connected via the inverter, it will give the complemented value. So, that either the gate signal should be 1 or the INT bar should be 1. So, the counter will count either internal clock pulse or external clock pulse. Then when to start means it depends on the TR bit position in the TCON register along with the gate and INT not. The gate should be 0 or the INT should be 1 to activate the counter. So, these are the 4 modes of operations in 8051. When the bit positions are 0 0, we call it as a mode 0. Mode 0 is called it as a 13 bit mode. Among the 13 bit, the 5 bits in the TL register and 8 bit in the TH register. Actually, only the 8 bits we are using loaded in the TH register. The TL register is used as a prescaler. Prescaler means the counter value or the generated frequency value will be divided by 12 in this mode. The another one is 0 1. When the bit position is 0 1, it represents mode 1. If the mode 1 is selected means you can use it as a 16 bit timer, right. So, whenever you want to initialize a 16 bit value means automatically you have to select the mode 1. In that case, you can load the TL and TH both with your required values, no need of the prescaler values. The another one is 1 0. When the bit position is 1 0 means it represents mode 2. In this mode 2, only 8 bits we are using. 8 bits we are using means it also call it as a 8 bit mode. The given value is loaded only in the TH register. From the TH register, the value will be moved to the TL register. Only the counter is reduced from the TL register. Okay. Whenever the TL value reached 0, then it will get the data automatically from the TH, then again start it. That is why the mode is called it as a reload mode. We are loading the value in the TH, it will be copied into TL, only the TL will reduce the values. Whenever the value is reduced to 0, automatically it will get the data from the TH and rotate it. Okay. That is why for any kind of repetition works or automation or for any waveform generations, we preferring the mode 2. The another one is mode 3. Mode 3, when both bit positions are 1 1, then we can say it is a mode 3. It is called it as a split mode because here we are using only the T 0. The T 0 register is used as a 2 8-bit register, TL 0 and TH 0. Here the T1 register is not used. Okay. So, among the counter means whenever the carry is overflow is occur, automatically it activate the TF, the timer overflow flag. The timer overflow flag is occur means it indicates it exceeding the size or the counter is overflow. Okay. This is a simple structure of mode 0. In mode 0, this is a structure which have a 13 bit. So, first 5 bits which are in the TL register, 8 bits in the TH register. The X represents either it might be a T0 register or T1 register. Okay. So, the given pulses are loaded, that will be divided by 32, then we are passing to the TH register. Whenever the TH register value is changing from the maximum value FF to 0 0, then the TF bit position it become 1. It become 1 indicates the overflow is occur. Okay. Then it will interrupt the controller what you want to specify, either whenever the overflow is occur, whether you want to switch on the motor or you want to replace the packing or whatever your required applications, based on that you can take the decision. So, for that it will interrupt the controller, what it indicates, it will give the information to the controller to take the decision. Whenever the interrupt is occur, the microcontroller temporarily suspend its current work, then switch over to the specified work. Okay. Suppose you are filling a number of bottles, okay. Suppose 10 bottles you have to fill it, then you pack it. So, 10 bottles are filled means automatically it will indicate the interrupt, then it will replace that pack, then the new empty cover will be placed for filling of next 10 packs. If you want to repeat, then you can do the repetition of the process. The next one is mode 1, which are pulses given and the pulses is loaded in the 2 8-bit registers TL and TH, both are 8 bits. So, totally 16 bits here you can use it. Whenever the overflow is occurred from 4 FF to 0, then the timer flow is occur. Okay. So, how the pulses are generated here means, suppose if you are use it as a timer, the internal clock frequency is taken, which is divided by 12, then the pulse is given to the AND gate, at the same time the timer run also 1. So, based on that now it started to count, the count value will be loaded in the number of pulses will be loaded in the T register, either it will be T0 or T1 register. After filling the value of 4F to 0 0, then it indicates the overflow is occurred. Okay. Then whatever you have programmed, according to that the controller will do the action. Another one is mode 2, here the pulses are given, right. Already we discussed the data will be loaded in only in the TH register. Suppose I am loading the value 10 means the 10 is loaded in the TH, then it is moved to the TL register, only the process is repeated here. The 10 become 9, then 8, 7, 6, 5, 4, 3, 2, 1, then 0. Okay. After that the timer flow, that is timer overflow flag will be set, at the same time this 10 will be again loaded to the TL register. So, it will get the data from the higher register and counting started in the lower register. So, this process will be repeatedly occurred without any interruption, that is why it call it as a automatic reload. This is circuit wise, the frequency which are from the internal divided by 12. So, the timer function we are generating with a timer run started with 1. If it is 1, then only it will start, if it is 0 means no. So, whatever you are giving that value will be loaded, then whenever the overflow is occurred it will be set to this is a 8-bit register. So, whenever FF reaches to 0, that time only we can use it. The same circuit in mode 1, suppose if you are using with the external timer or which is nothing but the counter. So, either T0 or T1 it will generate the pulses, the TR is 1. If both are 1, then automatically the count will start, because of mode 1 it will give it as a 16-bit counter values. Suppose if you are using the mode 2 means the same T0 T1 signal is given along with the TR is equal to 1 if both are 1. In the previous cases the previous one is 0, here both are 1. So, now the count value will be loaded. Whenever the count reaches from FF to 0, then it will indicate the overflow. The main difference between the timer and counter is the source of oscillator or the source of the frequency. Whether it is a internal, then you can call it as a timer, when it is from the external you can call it as a counter. This is a mode 3. So, the pulse input is given, whatever it will, that will be loaded in the TL naught, it is a 8 bit, the 8 bit changes from FF to 0, then automatically this overflow is occur. The another one which is a TH naught, here also it is a 8 bit register, the counter value will be changes from FF to 00H, then the overflow is indicated by the timer 1 overflow flag, because timer 1 is not used, that is why its corresponding timer overflow flag is used here. Okay. So, the both TF naught and TF1 is used for the T naught register itself. For T naught we are using only the internal pulse, for TH naught we can use it from the internal clock pulse along with the timer run conditions also. So, in today's session we have discussed the function of the timer and the difference between the timer and counter, when the counter will start, when the overflow flag is occur, right. So, based on that what are the special function registers in 8051, because before starting the timer you have to know how to activate the special function registers. Based on the number of bit positions in the T mode and TCON only, it activate the devices. Here if you are putting the value 1, then only you can read the data from T naught. If you are putting 0, you could not read it. Okay. So, the interfacing between the hardware and software by using the special function register TCON and T mode, after initializing these two value only you can initialize the counter value, then it will start like a normal counter applications. So, with this session